Welcome to This Explainer. Today, we're diving straight into what is arguably the most mind-bending frontier in science right now. For decades, the idea of controlling the physical world with literally nothing but our thoughts was strictly the stuff of science fiction and cyberpunk novels, right? But right now, today, in labs and hospitals all around the world, that fiction is being actively rewritten into reality. We're talking about technology that bypasses the body entirely and allows the human brain to speak directly to a machine.
Section 1. The Mind-Machine Connection. Bridging the gap between thought and action.
Now, bridging the gap between thought and action sounds kind of philosophical, doesn't it? But we aren't here to wax poetic. We're looking at the actual, tangible, almost unbelievable reality we're living in right now. To truly grasp the magnitude of this technological leap, we have to ground it in a real human experience. Picture this scenario, which is actively happening today in clinical trials like BrainGate and Neuralink. A patient, completely paralyzed by a severe spinal cord injury or ALS, sits in front of a computer monitor. They can't move their arms, they can't use a mouse, and they absolutely cannot tap a keyboard. Their physical connection to the digital world has been totally severed. But then, simply by intending to move, just by generating the thought of moving their hand, a cursor glides across the screen in front of them. They click, they type, they browse the internet, they even play video games like chess. They've completely restored their connection to the outside world through a tiny, incredibly sophisticated neural implant resting against their brain. It's wild. To really understand the profound emotional and practical impact this has, you just have to listen to the words of a patient who has actually used one of these systems. They said, "It's like having a new superpower. I just think, and it happens." Take a second to imagine the sheer liberation in that statement. For someone trapped in an unresponsive body, this isn't just some cool gadget. It's a miraculous restoration of their autonomy, their voice, and their agency. It's a genuine superpower granted by a silicon chip.
Okay, let's dive into this. Section 2. How neural implants work. Decoding the brain's whispers.
At the core of all this magic is something called a brain-computer interface, or BCI for short. By definition, a BCI is a direct communication pathway between an enhanced or wired brain and an external device. To really picture how this works, imagine you're standing outside a massive stadium packed with scratch that. Imagine it's packed with 86 billion cheering fans. That stadium is your brain, and the fans are your neurons, constantly firing off electrical signals. What a BCI does is drop a highly sensitive microphone, usually an array of tiny flexible threads with over 1,000 individual electrodes, into that stadium to isolate one specific voice or a very specific group of voices, and then translate that cheer into a command a computer can understand. So, how does that translate into action? It basically breaks down into 3 distinct steps. Step 1, the brain fires a signal. When you decide to move your arm, your motor cortex generates highly specific, localized electrical patterns. Step 2, the chip decodes. The implanted BCI array intercepts those microscopic electrical sparks. It then relies on advanced machine learning algorithms to filter out the noise and translate those raw neural spikes into digital code. And step 3, the device moves. That digital code is wirelessly transmitted via Bluetooth or a local transmitter to a computer, a robotic arm, or a smart wheelchair, executing the exact command the brain intended. It's a seamless translation from a biological whisper to a digital shout, and it happens in milliseconds.
Section 3. Current medical miracles. Restoring what was lost.
Right now, this technology is stepping up as a total medical hero, offering real hope to patients with severe neurological conditions. The immediate applications are absolutely transformative. We're restoring high-speed communication for locked-in patients, allowing folks with advanced ALS to text and email literally just by thinking about forming the words. We're seeing amputees and paralyzed individuals operating complex robotic limbs wired directly into their nervous systems, letting them feed themselves or grasp a loved one's hand with incredibly nuanced pressure control. And beyond movement, BCIs are being used to detect and intercept erratic brainwaves that cause seizures, actively treating epilepsy by delivering precise electrical stimulation before the symptoms even show up. It is a fundamental shift in how we approach neurodegenerative disease.
Section 4, the future of BCIs, beyond human limits. But here's where things get crazy. What happens when we take a technology designed to fix a deficit and apply it to a perfectly healthy brain? And this brilliantly illustrates the exact crossroads we're at. On the left side, we have restoring function, those medical miracles we just talked about. But on the right side, we have enhancing function. This is where we step firmly into the realm of sci-fi.
We're talking about healthy individuals opting for neural implants to increase their memory capacity, to communicate telepathically by beaming thoughts directly from one chip to another, or to interface seamlessly with AI at the speed of thought. The transition from therapy to enhancement is for sure the next massive, unavoidable leap for brain-computer interfaces.
Section 5. The ethical dilemmas. The cost of ultimate connection. Now, obviously, anytime we talk about fundamentally altering the human condition, we have to slow down and take a very deliberate look at the heavy implications here. A technology this powerful definitely does not come without profound risks. We are entering entirely uncharted waters, and there are compounding risks that we have to evaluate impartially. First up, data privacy. If a chip is reading your brainwaves, who exactly owns that data? We already stress about tech companies tracking our search history. Imagine them having access to your raw, unfiltered cognitive impulses or emotional states. No way. Second, hacking. If your brain is connected to the internet, could a bad actor theoretically hijack your implant? Could they feed you false sensory data, track your location, or restrict your physical movement? And finally, equity of access. If BCIs become the ultimate tool for cognitive enhancement, will they only be available to the ultra-wealthy? Could this create a literal biological divide between the enhanced and those left behind, fundamentally fracturing the human species? Section 6. Merging human and machine. A new evolution. These aren't just technical problems, They are profound philosophical questions about the trajectory of our species. So the crucial point is this. The hard boundary between our biology and our technology is rapidly blurring, and it might soon disappear entirely. We've spent all of human history using tools that exist outside of our bodies: hammers, cars, smartphones. But BCIs represent a future where we are intrinsically, physically linked with our own creations. The tool doesn't just sit in our hand anymore. It's woven into the very fabric of our minds, directly shaping how we perceive and interact with reality. Which leaves us staring down this massive drop-the-mic kind of question about our identity. If our minds are constantly connected to machines, if our memories are stored in the cloud, and our thoughts are mediated by algorithms, at what point do we stop being human and become something else entirely? Think about that for a while. Thanks so much for joining me for this explainer, and I'll see you in the next one.